I will assume that you have seen CPM Project Scheduling at least once, and the main focus here is to explain the skills needed in order to solve these problems. So let's say you have a project made up of a bunch of activities. For example, if you're making a building, you need people to draw the diagrams, and then you need to advertise for the future tenants to come in, and you need to hire workers and all that. So you have different activities involved in a big project, and let's say you can also figure out how many days each activities can be finished. Then you can draw a network diagram like this. The network diagram explains which has to be done first in order to get to the next activity. So for example, activity B requires activity A to be done. C also requires A to be done. But here activity F actually requires both D and C to be done. You have these structures, and the numbers down here is the duration in days, how many days it's going to take. So suppose you have such a network of activities. The common questions that can be asked is, I guess the most important question would be to fill in this activity chart. Now some of these places are easy. So for example, immediate predecessors, we just said that for B to happen, you need A to be completed first. And same with C. Remember that for F, we needed both D and E. So D and E. And A didn't have anything. A was the very start, so we put just a bar here to say that there is nothing before that. We can fill in all the other ones like that. Activity time was also given in this graph. Activity for A was 2, B was 3, C was 5. So 2 and 3 and 5. You can do this eventually to fill these two columns. Now what's harder is to figure out this thing called early start, late start, early finish, late finish, and then later you have to figure out what slack is, and also you have to decide whether the activity is critical or not. Now to fill in these, you need to do something called the forward pass and backward pass. So what I have here is a very handy redrawn diagram of the previous one. This is actually the same structure as the first one, A, B, C, just like that, and it's exactly the same thing. You can see that A, B, C, same thing, and the durations are now given in this square. Now these 4 blank squares are where we are going to put the early start, early finish, late start, and late finish. Okay, and to figure these out, you need something called the forward pass and backward pass. Okay, so let me explain what that means. First, activity A is the very first one. So you start with 0, and you just keep adding the duration. So since it takes 2 days, 0 plus 2, it's gonna finish at 2 the second day, and then at the second day, now B and C are allowed to start because A is finished. 2 plus 3 is 5, put that there. 2 plus 5 is 7. There's simple addition. Now that B is finished at day 5, you can start at day 5, and then 5 plus 1 is 6. Okay, and then here is the place where you have to think a little bit. For F requires D and C both to be finished, and you might think, well, since D is done, can we start activity F at day 6? Well, no, because C requires until day 7 to be finished, so F cannot begin before C is done. So the earliest F can start, the early start day is 7. Okay, that's why this one is called early start. And then 7 plus 4 gives you 11. On the other hand, E only relies on D, so E can start when D is 6. So we put 6 there. 6 plus 9 is 15. And then 11. G only depends on F. If one activity depends on another one only, then you just write whatever date it finished. Just put that here. 11 plus 2 is 13, so that's easy. Here's another juncture. Now again, you have to figure out when is the time that both are finished. Another way to think about it is, what is the higher number? 15 and 13. 15 is higher, so you put 15 here. 15 plus 5 is 20. 20 you put it here. And then 20 plus 2 would be 22. Okay. Once you have figured out the early start and early finish dates, now what we want to figure out is what are the latest dates that these activities can start and end. Now your goal is not to change the total duration time. So what we just figured out just by the forward pass is that the entire project takes 22 days to finish. 22 days. Okay, so the latest finish date would be 22 because we don't want to change that. And you just go backwards. That's called the backward pass. You start subtracting this duration. 22 minus 2 is 20. Put that same number here. 20 minus 5 is 15. Now, until here, you might think that the backward pass is producing the exact same numbers as the forward pass, but this is where it changes. So 15 is the latest time it can start. So at least by 15, it has to, H activity has to start. For activity H to start, that means E and G has to be finished by 15. So what you do is you put 15 here, and you also put 15 here. Okay, and this 13 and 15, you see this. For G, the early finish and late finish are different. They differ by 2. And that's what you call the float of this activity, or it's also called, I should write it. So here, float, also known as slack, is 2 days. In other words, activity G can be delayed up to 2 days, and still the entire project will finish by 22 days. So that's good to know. On the other hand, these don't have any difference between the early finish and late finish. In those cases, we say these are critical because there's no slack. So let's see. I want to write it here. So here, slack is 0. In that case, you call this critical activity. Okay. In other words, this activity is not allowed to be delayed. You have to start exactly at that date and finish at that date, or else you risk the project being delayed by however days that how many days you delay this thing. Okay. All right. 15 minus 2 is 13. 15 minus 9 is 6. Again, difference between 11 and 13 is 2. So you can say that the slack is equal to actually late finish minus early finish, or you can also write it as late start minus early start. So this is late start and this is early start. The difference between LS and ES is same thing as difference between LF and EF. They're both 2, so you can calculate slack in either way. Alright, here the latest start is 13, so you can still put this as 13. 13 minus 4 gives you 9. And when we do D, now we have some problem here. You have 6 here and 9 here. So if you just think about F, if F is the only activity that follows D, then you can say, well, you can wait until 9th to finish D. However, if you look at this E, it says it must start at 6 at the latest. So if you delay D any more than 6, then this will be delayed and everything else will be delayed. So that's not good. So this time, see, in in the forward pass, we are taking the higher number of the two. Here, in the backward pass, you take the lower number of the two. And 6 and 9, the lower number is 6. So you put 6 there. 6 minus 1 is 5. On the other hand, here's 9, so you put 9 there. 9 minus 5 is 4. Okay, 5 here. 5 minus 3 is 2. Okay, and then again, 2 and 4, you take the lower number, so this is 2, and this is 0. Okay. Now with this, I can actually fill in everything in this table. So here I put all the numbers according to the work that we just did. For example, here I have G that starts on ES is 11, LS is 13, the LF is 15, EF is 13. So I put those numbers 11, 13, and 13, 15 here. 11, 13, 13, and then 13, 15 here. Okay, and then if these two numbers don't differ, that means slack is 0. This does differ. 4 minus 2 is 2, so slack is 2. Doesn't differ, 0. Again, 9 minus 7 is 2. 11 minus 13, 13 minus 11 is 2. This is 0, and this is 0. Okay. Now, and you say that the activity is critical, meaning there's 0 slack. You're not allowed to delay this activity for any number of days, and that's called critical. And that's any 0 slack. Anytime you have 0, you put critical. Yes. Okay, so this is how you fill in the table. Maybe I'll also put no. Okay. Now in addition, you can also answer questions like determine the project's expected completion time. We already said that it ends at 22, so the answer for this would be 22. Okay. On what days can activity F begin without delaying the minimum project completion time? So here's F here. F can begin on 7th, but you can start at 9. The latest start is 9. So any day from 7 through 9, project F can begin. So 7, 8, or 9. And if F begins any day after that, then all the project will get delayed. Now another question, keep missing this. Another question is, what activity must necessarily be taking place on day 8? Well, think about anything that has day 8 in it. Here's 6 to 15, so day 8 is right here. Okay, 6 to 15. There's 8. Another place that day 8 is in here is here, right? 7 to 11. And oh, here there's also day 8 that belongs here, right? 4 to 9. So just identify all the day 8s. If 8 belongs to anything, just identify them. Now, for project F, you could start on 7th, and that means day 8 will be including during this activity. However, it could also be possible that day 9 is the starting time for that. If for some reason F got delayed, in that case, 8 wouldn't fit into this activity schedule. So if it's asking for must necessarily, then the only activity is just E. On the other hand, if you ask what activities could take place on day 8, in that case it would be E, F, and C. Okay. Now we know that C and F cannot take place in the same time, so in day 8 it could be C and E taking place at the same time, or F and E taking place at the same time. But whatever the case is, we know that activity E must be taking place. Now E lists all the activities that could happen day 14. Okay, let's look. 14 is here, and also 14 is here. 14 is included in both of them. So and I don't see any other numbers that include 14. So for E, it's a must. So E must happen. On the other hand, G may be taking place, or G may not be. Okay, so E and G are the activities that could take place on day 14. Okay. Last set of questions. What is the critical path? Well, we just figured out from the table. We could go back to the table and just write down all the critical paths like that, or we can look at this. It's easier to look at the solution here. So we know that the critical paths are this one. See, the two values don't differ, right? So these are 0 slack, which means 0 slack means it's critical. So these are the critical activities. So A to B to D to E to H to I is the critical path, and anything on this critical path cannot be delayed. So for the project to finish in the fastest amount of time, which is 22 days, the manager has to make sure that these projects are never delayed. Okay, what is the slack of activity C? We've already done that. Just simply take 4 minus 2, which is 2. That's all.